Alright folks, I want to do 9-3, 9-4, some rotations and dilations here. First thing I want to talk about, these are rigid motions, these are isometries, okay? Most of the time, rotations that are going to be done here are going to be through 90-degree increments, okay? And they're also going to be initially around the origin, okay? Whenever we do a rotation, we need a point of reference, or a lot of times called a point of rotation. Right now, that's going to be the origin, okay? I'll show you a strategy for changing that, okay? In actuality, like I said, these are the easiest ways of doing rotations, but we could do any degree we wanted to. It's just that the algebra involved in that is extensive, okay? So we're going to kind of stick initially to these four. So the following slide shows how a rotation around a point is conducted regardless of the angle rotation. Okay, so you see this bullet says you need a compass or a protractor to be able to do this. But this is the idea. What you do, it says, starting with this image or pre-image ABC, it says that a line is drawn from each point, and here we're going to use the vertices. All right, so we're going to start with any point on this image here, or pre-image over here, A, and I'm going to draw a line to my center of rotation. When I draw that line to my center of rotation, that essentially becomes one of the sides of the angle of rotation. So then we would put our protractor, kind of maybe implant a quick protractor. I don't know if I got a protractor image. No. So what we would do, we'll just do it here in different color. We would basically put a protractor, we'd line it up right here, okay, and let's say that I was looking for 90 degrees, so I would obviously line it up, and I would then start tracing through 90 degrees, and that would then give me the angle of rotation, okay, so it would develop this angle right here of 90 degrees. So I know then when I extend this line that the rotation of A, essentially the A being the pre-image, the image of A is going to be on that blue line somewhere. Okay. The next thing I do is I then find this distance here. Okay. So I find that distance, and then I'm going to replicate that distance right there, and that will then give me the location of A prime. I then do that to every other point that is on here. Okay. So I would do that with B, and I would do that with C, and that's going to then give me B prime and C prime. Once I have A prime, B prime, C prime, connect them, and then I've got a rotation of ABC around that point by 90 degrees. So the idea is, well, does it have to be 90 degrees? No, it does not. It could be, 38 degrees, and it would just mean that on my protractor, I trace through 38 degrees on my protractor, and it shows me then the locations of those image points. Okay. When we do rotations around a fixed point, okay, here are some rules here that happen. Okay, so the rotation turns a figure through an angle about a fixed point called the center. So a positive angle of rotation turns the figure counterclockwise. So if I'm looking at a clock, okay, and I'm going to implant my clock in the X and Y axes, we're going to rotate that way. That's counterclockwise. Okay. That's how every single one of these is originally conducted. Okay, a negative angle of rotation is moving clockwise. Okay, we call this a direct isometry because distances are preserved; they do not change. Essentially, it's a rigid motion. Okay, so if I want to go a rotation 90 degrees, so these are all my clockwise rotations, and we kind of see. Maybe I can get a GeoGebra here to kind of prove these. Points to you, or these rules. Let's put our origin in. So I go 0, 0. Okay. Let's take point P and put it at, let's just go 5, 2. So if I put it at 5, 2. It's going to be 5. It's going to be that way. Okay, so 5, 2. Let's see if we can get the name. value there. Okay. So now what I'm going to do is I'm going to ask this thing to rotate. So rotate P around A. I'm just going to put A here, A degrees, and we'll fix this here in a moment with my slider. And I'll just say that my slider, I want to go from 0 to 360 degrees, but by increments of 90. So that'll give me the 90, 180, 270, that we can see our rotations here, okay? So right now you see with a 0 degree rotation, obviously P and P prime are the same point, so they're the same coordinates. But if I go a 90 degree rotation, okay, that's where P prime ends up. And if you look at this, kind of showing you what I did earlier with the graphic in OneNote, if I were to put a protractor on top of those two segments, the angle between them is there 90 degrees. So you see that we did rotate this 90 degrees, okay? We could put a circle on here to maybe make it make sense that it was a rotation. And if we think about that circle, each of those black segments from A to P and A to P prime are a radius of that circle. And radii of circles are congruent. That means the distance from A to P and the distance to A, P prime are the same. Thus, we currently have a true 90 degree rotation of P to get P prime. Look what happened to the ordered pairs. Okay, kind of using what we did with the translations and reflections. Let's use that notation real quick. If I call this point A and that point B, okay, over here, doesn't it become B and then A? But B ends up being negative. So, going back to this here, we've got this 90 degree rotation. They say if X comma Y is on your pre-image, that's on your pre-image. I don't know why I won't let me write.
I guess they do, but on the bright side, more TV cuddle time, right?
Bear with me. There we go. So if this is on my pre-image, then this point is on my image. Now remember, this is still an X value and that's still a Y value, and that's why I like using A and B. If I say 90 degree rotation of the point located A comma B, then it's going to become negative B comma A, where I know that that's an X coordinate and that's a Y coordinate of my pre-image. That's an X coordinate, that's a Y coordinate of now my image. So that's where that rule comes from, okay? Now if I do a rotation of 180 degrees, okay, so this thing here goes to 180, you see there, if this was A comma B here on P, then becomes negative A, negative B, negative A, negative B. So a rotation of 180 degrees of A comma B turns into negative A, negative B. Okay? And 270 degree rotation, we see A comma B, this becomes B comma negative A, B comma negative A. So rotation of 270 of A comma B becomes B comma negative A. Just some ways of helping you remember these. You know, the 90 degree and the 270, the structure is really the same. They're both B comma A. 90, the way I remember this, 90 comes before 270, so I'm going to negate the first thing I see here. Okay. And then 270 comes second, so when the 271, I negate the Y value. That's the way I remember it. Somehow you've got to come to kind of come to terms with how you can memorize these rules. If we look at something like this, so I'm going to just go ahead and hit Control All here, Control C, we'll open another window. and paste all this stuff there as well. Alright, so hopefully we can get this to awesome. Alright, so if I go 90-degree rotation that way, okay, so a 90-degree rotation clockwise. So what I'm showing here is movement from there, there. So you can view if it's a clock, we're going counterclockwise, counterclockwise. Let's do this. Let's take this thing here, and let's say that I want to go. All right, I gotta just or fix this a little bit, but let's see here. I'm not sure that's doing what I want to do. There we go. Alright, so let's see if that will work. There we go. Alright. So if I want to go, so I got 90 degrees going counterclockwise. To get to that same point, if I go that way, so what direction is this point going? So now it's going from here to there. It would go clockwise, and I eventually get to 270 degrees. So 270 degrees clockwise is the same thing as these two images, P prime here and P prime there, or P prime sub 2. They're the same ordered pair, but the way I got there was a different path. So what I want you guys to understand is that and this is true no matter how you do this, but a 90-degree counterclockwise is equal to a 270 degrees clockwise. A 180-degree counterclockwise is equal to 180-degree clockwise. So that's kind of a one-to-one relationship there. And a 270-degree counterclockwise is equivalent to a 90-degree clockwise. Okay? If you can remember these things, that's going to help you adjust when the question says rotate counterclockwise or rotate clockwise. You kind of have to use this comparison, because if we're going to use this rule, we don't necessarily have a rule, we don't memorize rules for clockwise rotations. We remember this relationship here, which if they give me 270 clockwise, then you're going to transfer it. No, I'm not going to do 270 clockwise. I'm going to do 90 counterclockwise, and that will then tell me to use that rule there. All right. So what we do here is we take our ordered pairs, and we're just going to rotate them. And so this one here I'll kind of do in maybe a little bit greater detail than the next few. But if we were looking at, so that point right there is 2, 1. This one here, 1, 2, 3, 4, 5, 6, 6, 1. So then this one here is 2, 3, and then 6, 3. Okay. So I'm just gonna call this one. Let's call that point A. Call this one B, C, and D. Okay. If I'm going to do 90-degree clockwise. Okay, sorry, counterclockwise. These are all counterclockwise. If it doesn't tell you, then the assumption is that you're moving counterclockwise. So if I go R of 90 degrees, rotation 90 degrees, okay, again, you might see a lowercase r here instead, but it doesn't matter, of an A, comma B. Remember that rule is that it becomes B, comma A, and then you're going to negate the B, okay? So what are the points that we've got here? And this is the way that I do this. I think this is just the most efficient, quickest way. I'm going to list these points: 2, 3, 6, 3, 6, 1, and then 2, 1. And then remember, this was A, B, C, and D. What is that going to generate? That's going to give me A prime. This would go to B prime. This would go to C prime. This would go to D prime. But now I just flip these. So it's just going to be 3, 2. I just flip that order pair, and I make that one negative. Same thing here. Flip the ordered pair, so 3, 6, make that one negative. Flip this one, 1 comma 6, make that one negative.
Give us a feather.
Flip the last one, 1 comma 2, make that one negative. Now go plot those points real quick. Negative 3, 2. So negative 3, 2, there would be A prime. Negative 3, 6. 1, 2, 3, 4. Actually, 1, 2, 3, 4, 5, 6. So there's B prime. C prime is negative 1, 6.
That was our last
So there's C prime, and then here will be D prime. And we connect those, and there is now our image. But what I want you guys to see is, how was this a rotation? How was this a 90-degree rotation? If you go back, remember, that point, so I'm going to line up, so this was, I guess that was A prime, and this was D prime here. Sorry, my 1-year-old's knocking over chairs. All right, so if I go from D to the origin, to the point of rotation, and then travel to D prime, we can see that the slope of that line right there would be down 2 over 1. So it'd be a negative 2 slope. This one here would be a rise of 1 over 2, so that would be a 1/2 slope. Well, if I multiply those, I get negative 1. So that's a proof right there that that is a 90-degree angle. And because I'm using that, you know, essentially the slope formula is developing distance for us, we could figure out that those two black segments I just drew were the same distance. Now you can do the same thing from A. We can go from, let's see here, A to A prime with the purple here, and you can do the same thing and see if that's a 90-degree angle in purple. You can do that from every point B to B prime, C to C prime, so everything got rotated 90 degrees. Okay, if we're going to do a 180-degree rotation, okay, of A comma B, so again using those same points, so A was at 2, 3, B 6, 3, C 6, 1, D 2, 1, and that's going to become obviously A prime, B prime, and C prime. A prime, B prime, C prime, D prime.
You're fading too. One more sneeze and you'll be great.
If I'm going to do a 180-degree rotation, that becomes negative A, negative B. So then this will be negative 2, negative 3, negative 6, negative 3, negative 6, negative 1, negative 2, negative 1. And that's all you've got to do. And that, if you plot those points, then you're going to see that you get a 180-degree rotation, and it's going to put your figure down here in the fourth quadrant, or third quadrant, sorry. Okay. Let's say, to give you one, let's say we want to take these points. Okay, so the directions would be something of the form like rotate 270 degrees clockwise. Okay, so moving clockwise, we would be moving that much. If I had a point like right there, I'll move it 270 degrees clockwise. Well, 270 degrees that direction is the same as moving that direction 90 degrees. So rotate 270 clockwise is the same as rotate 90 degrees counterclockwise. So when they give me these directions here in red, I'm actually going to transfer them to that because our rule is written for counterclockwise rotations. So I have 90, and that counterclockwise rotation then is that rule right there. Sorry, counterclockwise rotation is that rule there. So whenever, that's kind of the game you play. Whenever they talk about moving clockwise, you want to transfer it to what that would be in a counterclockwise movement and then do that work. Okay? So what happens if it's not the origin? What do we do if this is not the origin? So the process is the same, except for we've got to do, I think, 1 or 2 steps prior to get the rotation around a point that's not the origin. Okay. First thing you're gonna do is you're gonna locate the center of origin. Okay. And we're going to view that new center of origin as like a pseudo origin, a fake origin. Okay, and we'll label it 0, 0. Okay, we're then going to go around and rename all the points that they gave us in the problem off of or in respect to that point being called 0, 0. Okay, then we will pull from our list of rotation rules the correct rotation rule, and we will apply that to these new points that we found in this second bullet. Okay. Once we do that, then we'll go back and we'll rename our new points off of the actual origin, the true origin. So that's kind of the process here, and it'll make a little bit more sense when we see an example. There is some algebra that you can do that might expedite this. I want to skip over that algebra right now just to keep these examples a little bit shorter, or these videos a little bit shorter. There are, and this goes for everything that I do here with these videos, there are a lot of other more detailed examples on my website that I've used in previous classes when we're actually in class together that might be of benefit to you. Okay, so by no means are these the only examples that you have at your disposal. All right, so here's the idea. We want to rotate y, which is at 4, 1, around the point 1, 3. So I'm going to put 4, 1 in. So 4, 1 is that point right there. So I'll call that y. And we want to rotate it around the point 1, 3. Okay, so this is my kind of fake origin. Okay, so I'm going to recall this point here. I'm going to call that now 0, 0 instead. Okay, so I'll highlight that in green. Remember that is the fake origin. So if that's the fake origin, I'm going to call that 0, 0. What would 4, 1 or y be called off of 0, 0? Well, that would mean that y is 1, 2, 3, and then down 2. So this would be 3, -2. Okay. So what I'm really going to do here, guys, is I'm going to actually take this point here and rotate it 90 degrees around this fake origin. Well, let's go back to, and we're going to do this 90 degrees, and it doesn't say which direction, so we're going to assume counterclockwise. Remember, that rule was this. Okay, but it was only if, we can only apply that if you were rotating around an origin. Okay, that's why we had to bring in and rewrite that as kind of a fake origin. Now what I'm going to do is say, okay, well then 3, -2 is the point that I'm going to rotate around this fake 0, 0. So when I do that, it says, flip-flop the ordered pairs, -2 and 3, and then negate this first one. So negating a negative makes a positive. So now I'm going to go plot 2, 3 off of this red origin. So you go 1, 2, and then up 1, 2, 3. Should give me that point right there. Okay. So off the red origin, obviously, like I said, that's 2, 3. But what is that point off the original origin? Off the original origin, which is what because the problem doesn't know we did that. They didn't know we put in this red set of axes. Off of the original origin right there, it would be to the right 1, 2, 3, and then up 1, 2, 3, 4, 5, 6. So that point is actually located at 3, 6. Okay, that's what I'm looking for. The point y rotating around the point 1, 3 by 90 degrees will turn into 3, 6. Let's just double check to see if that makes sense using GeoGebra. Okay, so I'm gonna put 1, 3 in. I'll put 4, 1 in. Okay, and I want to remember I want to rotate B around A. And in this case, we're just going to do it 90 degrees. And what point did we get? We got 3, 6. Okay, which is exactly what we came up with here. All right. Now, I will do, I guess, the quick way of explaining this with algebra. If you think about it, how can I go from, let's say, how did I go from that point there to getting that point there? I subtracted out, to go from 4 to 3, you subtracted out that one right there. to go from 1 to -2, you subtracted out that 3 from that 1. Okay? So I'm going to write this. I'm going to say the point to rotate. So point to rotate, or the point that you're going to actually apply your rule to. The point that you're going to apply your rule to is your, how can we write this? We're going to say, given point, which in this case would have been y, and you're going to subtract away from it the point of rotation. Okay, so you're going to take your given point y and subtract away from it your point of rotation, or your center, or maybe we'll say center of rotation. Okay, that is going to give you, essentially in this case, that 3, -2 number, or order pair. Give you that. Apply your rule to that. Okay, apply rule to that. And what that would have given you was this 2, 3. Well, how did I get 2, 3? How do I go back to making that? Because the answer turned into 3, 6. We'll take your 2, and how do I make it a 3? I add back in that 1 that I removed earlier. How do I make this 3 into that 6? I add back in that 3 that I removed earlier. So once you apply your rule, okay, so this, you're going to get then a rotated point, okay, then add back in the center of rotation, and that will give you your final answer. Okay, so kind of do that here with this one. So we want to take and rotate around the point 3, 2. Okay, so 3, 2 right there, and I want to go 90 degrees. So 3, 2 is that point. So this would be 4, 5, 2. Zoom in here a little bit. So that's 5, 2 right there. We'll call that A. This is going to be what, 5, 4. C is going to be, so that's 5, 6, 7, 8, 8, 4, and then D would be at 8, 2. Okay, and we're going to rotate around 3, 2. So here's what I want to do. I want to take my points A, which are at 5, 4. Sorry, 5, 2. B at 5, 4. C at 8, 4. And D at 8, 2. Okay. We're going to subtract out your center of rotation. Okay. So when I do that, that's going to give me my center of rotation is 3, 2. So that's going to turn this point. So I'm going to subtract the 3 from this 5 and the 2 from the 2. Then we'll do the same thing down for all these points. So subtract the 3 from all these x's. So that and a 2 from this, give me that. Subtract the 3 from there, gives me 5. And a 2 from there gives me 2. And then here it's going to give me 5, 0. Okay. Now you're going to apply, in the second step here, apply the rotation rule. Okay, and again, we're just doing 90 degrees here. I know a lot of these are 90 degrees, but if it was 270 or 180, you would just go capture that appropriate rule. So now let's apply a rotation of 90 degrees, which says you start with AB, it's going to turn into negative B, comma A. So now I'm going to flip those, 0, 2. Now if I make 0 negative, it's still 0. These two flip 2, 2, flips to negative 2, 2. This becomes negative 2, 5. And this one becomes, again, negative 0, 5. But then again, obviously negative 0, 0, 0. Okay? Now you're going to add back in the point that you subtracted out. So add back in center of rotation. And remember, center of rotation was the point 3, 2. Okay, so I'm going to
You gotta listen to your mama, okay?
add 3 to that,
Mama needs
so it gives me 3.
space.
Add 2 to that, gives me 4.
Thanks, guys.
Add 3 to that, gives me 1.
Listen to me.
Add 2 to that, gives me 4. Add 3 to this, gives me 1. Add 2 to that, gives me 7. Add 3 to that, gives me 3. 2 to that, gives me 7. Okay, so I'm just gonna go to Geo. So that should be then my final image. That should be the rotated rectangle. So let's see if that happens.
Mama bee.
Thanks, Drew. That's how things work. This trip
Okay, so I set this up. Here's our point 3, 2. Here are points of this rectangle. I want to rotate it. I'm going to rotate that around point R by 90 degrees. I'm going to go counterclockwise. Hit OK. And that gives me these points of A prime, which was 3, 4. So I'm going to just kind of compare this to what we came up with. We got 3, 4 for A prime. Okay. B prime says it's 1, 4. Did we get 1, 4 for B prime? Yes, we did. C prime is 1, 7. That's what we got. And D prime is 3, 7. That's exactly what we got. So every time that I ask GeoGebra to do this, understand that it's in the background, almost instantaneously, it is doing this work right here that we just kind of laid out. Okay, so that's in a nutshell how you do rotations. Now, like I said, most of these were 90 degrees. But if I were going to do a 270, it's just making sure that I go pick this 270 rule and I use it. Okay. If I wanted 180 or if I wanted to go clockwise instead of counterclockwise, I just make sure I have the right rule and then to go apply that rule to every point that they're asking me to manipulate. Okay. Let's see what time we're at here. Let's go ahead and stop right there with this video. I'll pick up a second video and do dilations with you. Dilations are not hard. If you understand rotations, dilations are really the exact same structure. Okay, so it involves multiplication, but you should be okay with that.